In this lesson we will discuss voltage division in a series circuit. In the circuit shown, the following voltages can be determined. V1 is equal to I times R1, V2 is equal to I times R2, and V3 is equal to I times R3. Therefore, I is equal to V1 divided by R1, which is equal to V2 divided by R2 and V3 divided by R3. From V1 divided by R1 equals V2 divided by R2 and V2 divided by R2 equals V3 divided by R3, we derive the following relationships shown. V1 equals V2 times R1 divided by R2, V2 equals V3 times R2 divided by R3, V2 also equals V1 times R2 divided by R1, and V3 equals V2 times R3 divided by R2. The voltage drops are proportional to the values of the resistors. The same rule of proportion can be applied to power dissipated in the individual resistors. P1 is equal to I squared R1, or V1 squared divided by R1. P2 is equal to I squared R2, or V2 squared divided by R2. And P3 equals I squared R3 and is equal to V3 squared divided by R3. By substitution, we know that I squared equals P1 divided by R1, which is equal to P2 divided by R2, and P3 divided by R3. By substituting this equation into the previous power equations, we now get the following relationships. P1 equals P2 times R1 divided by R2, P2 equals P1 times R2 divided by R1, P2 also equals P3 times R2 divided by R3, and P3 equals P2 times R3 divided by R2. The source voltage is divided between the resistors in a manner determined by the resistor values. V1 is equal to I times R1, and I is equal to E divided by the total resistance R. Therefore, V is equal to E divided by RT times R1, which is equal to E times R1 divided by RT. And therefore, E is equal to V1 times RT divided by R1. The last two equations represent the voltage division rule. Thus, the fraction of the source voltage developed across the resistor is equal to the ratio of the resistor's value of resistance to the total resistance of the circuit. If there are two resistors in series, then V1 equals E times R1 divided by RT, which equals E times R1 divided by R1 plus R2. And V2 equals E times R2 divided by R1 plus R2. For power, the relationships for a two-resistor series circuit are PT equals I squared RT. P1 equals I squared R1. I squared is equal to PT divided by RT, or P1 divided by R1. P1 is therefore equal to PT times R1 divided by RT, and P2 equals PT times R2 divided by RT. Let's do an exercise using the circuit shown and calculate the value of V3, E, and P2. Starting with the relationship V3 divided by V1 equals R3 divided by R1, we get V3 equals V1 times R3 divided by R1, and therefore V3 equals 7.3 times 4.5 divided by 3.2, or 10.3 volts. To find E, we know that E is equal to V1 times RT divided by R1, or 7.3 times the quantity of the total resistance 3.2 plus 6.4 plus 4.5 divided by 3.2, or 32.2 volts. To determine P1, we know that P1 equals V1 squared divided by R1, or 7.3 squared divided by 3.2 times 10 to the third, which equals 16.7 milliwatts. Continuing, we know that P1 equals I squared R1 and P2 equals I squared R2. We also know that I squared equals P1 divided by R1 and I squared equals P2 divided by R2. Therefore, P1 divided by R1 equals P2 divided by R2, and P2 therefore equals P1 times R2 divided by R1, or 16.7 times 6.4 divided by 3.2, and equals 33.4 milliwatts.